Hello everyone, welcome to Periyar University SWIM portal. First of all, I thank for your presence here. Myself, Professor Anbalagan, Professor in Geology, Director Center for Geoinformatics and Planetary Studies in Periyar University. I am going to speak about the basic concept of remote sensing, including the definition, application, remote sensing processes, electromagnetic spectrum, and the advantages of remote sensing. In fact, the remote sensing technique was extensively utilized during World War time for military applications. Later, this tool emerged as important technique for civilian applications in the last 6 decades. In early days, the aerial survey was conducted by using balloons and kites, and aerial photographs were interpreted for various purposes. Later, in 19th century, the pigeons were used for aerial photography. In fact, the pigeon aerial photography was invented in 1907 by German photographer New Brunner. He used a homing pigeon, was fitted with an aluminum pressed light-weighted time-delayed miniature camera for capturing the aerial view of the terrain. Pigeon photography was used extensively during World War I and World War II battlefield time, particularly for aerial reconnaissance survey. Later, USA Central Intelligence Agency, they have developed a battery-operated camera, particularly designed for pigeon aerial photography. After Second World War time or during the World War time, flight was extensively used to capture the aerial photography. So now we broadly have aerial photograph or aerial remote sensing is a major contribution in remote sensing data analysis. So the aerial photograph taken in different altitude, low altitude, you can have the large scale aerial photograph, or middle altitude, you have medium level, medium scale aerial photograph. If you take the photograph in high altitude, you have the small scale aerial photograph, but you have the terrain coverage, large terrain coverage. In fact, nowadays the satellite remote sensing replaced the aerial remote sensing from 1970s when USA launched Earth Resource Satellite series of Earth Resource Satellite, the name of Landsat satellites. It started from low resolution satellite around 80 meter resolution. Later we have 30 meter resolution. At present now we have 1 meter resolution. You can capture the very even small features, terrain features you can identify from satellite remote sensing data. The planetary mission captured the planetary surface of the planetary body, also a part of remote sensing data. What we are seeing in the slide is the image of a planetary surface of the moon. You can see the highly undulating terrain topography, meteoritic craters on the surface of the moon. In recent time, drones were extensively used for aerial photography at low latitude or low altitude. We can cover very fine terrain features at a shorter distance. The scale of photograph also is very good, and we can utilize this type of drones for recognizing survey and also for various applications. If you look into this, the development of remote sensing in fact, the remote sensing, the technique started in 1858 when the first aerial photograph taken using balloon. In 1900, aerial survey photographs were taken pigeon camera. After invention of flight, uh, particularly during World War time, Second World War time, the flights, aeroplanes were utilized for aerial survey to capture the enemy's land and their movement. 1950s, the space program was initiated, started with the Sputnik, being initially a meteorological satellite. And in 1970s, USA started Landsat 1 series of satellites, Landsat 1, 2, 3, 4, now we have a Landsat 6 or 7 number of satellites. They have wide variety of spatial information from 80 meter to 30 meter. Now the panchromatic data have a few meter resolutions. India also entered in 1990s. IRS 1A satellite was launched in 1989. We have also very good spatial resolution. And now recent Cartosat satellite have very good spatial resolution for various applications. Let us see the remote sensing definition. Remote sensing, if you simply define, it's collecting information at a distance using some device without any physical contact. We properly define in textbook, remote sensing is the science and art of obtaining information about an object, area, phenomenon through analysis of data acquired by a device that is not in contact with the object, area, or phenomena under investigation. Or broadly, also you can define collecting and interpreting information about a target without being in physical contact with the object. Aircraft and satellites are the common platform for collecting remote sensing data. You get the aerial photographs and satellite images from that platform. In general, remote sensing employed utilizing the electromagnetic energy as a source of energy in the form of reflected light or heat energy. Microwave radar waves are utilizing for remote sensing purpose for detecting and measuring the targets. Let us see about the advantage of remote sensing. The main advantages of remote sensing is it is a global coverage. A single satellite mission cover the entire area, including the continents and ocean portion. That is possible. We can have a perspective view. That is not possible if you take photograph, terrestrial photograph, or if you are do the survey in the ground. It's not possible. But using remote sensing, either aerial photographs or satellite image, you can have the perspective bird's eye view of the terrain. That is one of the advantages. Then we can have the different types of color composite image. That means you have the vegetation in the infrared region, water body in blue region, or you can have the urban area in different region. You can generate a different color composite image so that we can interpret the different features very clearly. What you are seeing, the color composite image, the water body looks very dark color, and all vegetation looks the bright red color. The remaining area can have the urban area. Another advantage is you have this the coverage of the data in broader portion of the spectrum. You have the coverage in visible part of the spectrum. You may have the near infrared region or thermal regions. Say for example, we have the from 500 nanometer to 2500 nanometer, you can have the spectral data, the reflectance value. So you can have this spectral graph, also the image, and from that you can interpret different types of features. So the broad spectrum coverage is possible in satellite data. Other advantages, remote sensing data, it provides the repetitive coverage. That means the same area it can be covered by the same satellite data by once in week or once in 20 days. On this technique, easy to collect data for variety of scales and resolution. We have the high resolution data, also the low resolution, and the different spatial resolution also you can have them for same area. It's possible. And if you have the same image, can be utilized or interpreted for the various applications. If you have an image, you can apply for geology. Another person with the agriculture background, he can utilize for crop inventory, or soil scientist, he can utilize the remote sensing data. And also you can have the sensor specific image output. Simultaneously you can have the image in blue part of the spectrum, red part of the spectrum, or near infrared part of the spectrum. So that having image in different part of the spectrum simultaneously is possible through remote sensing. Remote sensing data also provides georeference data. That means you can utilize and you can match with other type of data like topographic data, because it is geo-registered data. Also, it's in digital format, raster format. You can process it with the help of computers, software. And some portion of the remote sensing image will operate in all seasons, irrespective of monsoon or cloud conditions or night time, like a micro data. You can collect the information about the terrains even in the night time. Particularly this type of data is useful during the flood season. If you have the typical remote sensing program, there's 5 parameters important. One is electromagnetic spectrum, which have the characteristics of scattered energy, absorbed energy, and reflected energy. Then remote sensing sensors, it include the photographic camera, which is aerial, scanner, radiometers, and platforms at a different level. It include the data acquisition. You have the terrestrial platform, aerial platform, and a space platform at hundreds of kilometers above the Earth's surface. Once you obtain the information, you have this rectification and enhancement process with the remote sensing data. In interpretation, to some amount of data, ground truth information also you have to add. And finally, we are doing thematic map integration for various different applications that will be ultimately used for the decision makers. So these are the parameters involved in a typical remote sensing program. Remote sensing processes. So it has a different component in the remote sensing processes. One is the sun energy, the source available for remote sensing data capturing. When the energy comes from the sun to the Earth's surface, in between it has atmospheric interaction in the form of scattering, absorption. So once the remaining energy hit the target on the surface of the Earth, it reflected back. Again, it goes through the atmospheric interaction. It reaches to the sensor, which is fitted in the satellite mission. It captures the reflected energy or the thermal energy, emitted energy in the satellite. That energy will be again transmitted to the ground station. The ground station receives the data in the form of spectral signature, emitted energy. It will be processed and it will be supplied to the end users. So end users, they will process the data with the basic information idea. Finally, they will generate the different thematic maps in the form of information. There are 3 basic types of remote sensing platform. One is ground-based or terrestrial platform, you can keep the camera or spectroradiometer in the tripod and collect the spectral data or terrestrial photographs in the ground. The next level is aerial platform. Normally, flight were using these photographs, capture the photographs. Third one is a spaceborne satellite remote sensing data platform. It is in at least in 700 to 800 meter above the terrain surface. Remote sensing sensor, there are two types of sensor. One is active remote sensing sensor, where the source of energy is generated from the satellite mission, transmitted to the surface. Again, it receive the information, analyze the data. It's artificially the energy produced and send it to the surface, and getting the features, the characteristics. Next one is a passive remote sensing. So their energy is utilized, naturally available energy is utilized for satellite data analysis in the form of visible spectrum or infrared spectrum, and reflected energy will be registered by the or captured by the sensor in the satellite. Electromagnetic spectrum is one of the important components or the energy source available for remote sensing. It's nothing but ordering of electromagnetic radiation according to wavelength or frequency or energy, starting from gamma rays, X-ray, ultraviolet rays, infrared rays. In between you have visible light, radar, radio waves, or television waves, like that. So out of various spectrum, the optical range, X-ray, visible and far infrared, from 0.02 micrometer to 1 micrometer, micro range 1 millimeter to 0.8 meter, are useful for remote sensing application. Optical spectral region 0.4 to 14 micrometer, and micro spectral region 2 micrometer to 2 millimeter to 0.8 meter. So once the energy reach to the Earth surface, how it interact with the Earth surface features, it is an important aspect. So the energy is incident on the features, it gets reflected or absorbed by the features, or it transmitted. So EA is the lambda is the incident energy, maybe 100% you consider, and R is a reflected energy, T is the transmitted energy, and A is the absorbed energy. We are looking for how much energy is reflected from the particular feature. So the proportion of energy reflected, absorbed and transmitted will vary for different Earth features depending on the material type and condition. So for example, rock will have the different amount of reflected energy, soil will have a different amount of reflected energy, forest cover have a different amount of reflected energy. Even within a given feature type, the proportion of reflected, absorbed and transmitted energy will vary at a different part of the electromagnetic spectrum. So that variation in the reflectance properties is very, very important. So we can derive a calculation ER lambda equal to energy incident EI minus the sum of energy transmitted ET plus energy absorption EA. So the reflectance amount of value we can refer as a spectral reflectance. We can study the characteristics of Earth surface features, quantify the portion of incident energy and how much energy is reflected from the particular object. So the spectral reflectance is the ratio of energy of wavelength
reflection from the object and energy of wavelength incident upon the object. So here the rho lambda is expressed as the percentage of amount of energy reflected. So for that reflectance, we can draw the spectral reflectance curve with reference to different part of the electromagnetic spectrum. How much percentage of energy reflected from blue waves or green waves or red portion, infrared portion. We can draw a spectral reflectance curve. What we are seeing here, the figure, it's a reflectance curve plotted for different earth objects like water, green grass, dry grass, and soil cover. In the x-axis we can see the wavelength in nanometer, and y-axis we can see the percentage of reflectance 0 to 50. So that water, you can see that reflectance only in the visible portion, that too in the blue region. After that there is no reflectance, it's a total absorption. And if you look into the green vegetation, there is a sudden rise in the reflectance value after the red region, that is in the infrared portion of the spectrum. Before that we have reflectance in green portion also, but we have a excellent reflectance, high reflectance value. It goes up to 40-45% in the near infrared region. Again it will reduce in the mid infrared regions, but of course in between there is some absorption. Again